The TC298 adapter with a TC298, so we set the trigger like this, but in JTAG mode. So to do that, we don't need to change any connection, everything stays as it is when you get the adapter. Just connect to the processor. Pin number 1 is here, so this is our reference. Let's install the chip first. Done. Now let's check all the angles to see if there is any misalignment. It looks all okay. Okay, now we connect in JTAG. We need to give power over here. We have power. Now the JTAG port is this one. So we connect this one to our Infinite programmer. Once connected, as you see, we'll have 5 volt here. JTAG is connected like this, and 3 volt are over here. This should not be wrong. Then you can open the software for memtool and select the TC298. If you don't have it, here is how to create one. Go to new, then create a key targeted configuration step by step. Next, family should be Infineon 3-core family. The next one. Processor, we select TC298T with final B. Next, here we select the JTAG interface, go to setup, then just confirm. Then we can continue, complete. We save the file as 298 TC whatever. Then we select it and we can connect. If the connection is correct, then here we will get ready for memtool command. Okay, now we need to select the reading. Here we have P-flash0, P-flash1, P-flash2, P-flash3, and then the DF-EEPROM, DF1 and UCB. So all those data, we can read them one by one. Since there are 4 flash memories and each of them is 2 megabytes, we will have 4 files, but a lot of tools will merge those files together if you compare, for example, with a flex readout. So nothing to worry about, just need to do it manually. So let's read the first P-flash0. We go here and we specify the section over here. Now we need to have a size of 2 megabytes and we need to get exact addresses, so that's why we need to check here. Starting point is 800, finishing point is 801FF. So we go here, we select new, here we write 8000, and here we select 801 FFFF. Okay, total is 2 megabytes, so no mistake here, and we can start reading. Now it's reading the first P-flash. Done. So this P-flash is now here, we can just save it as P-flash0. And when we save as P-flash0, the format needed to write with this tool will be hex, but if you want to compare it with a readout from another programmer, you will need bin. So I recommend you to do both, so that you can have both formats and it will be easier for you to use them however you need. Just save again, and then you have P-flash0 298, and this is the one we need for writing. Then the next step will be exactly the same. You move into P-flash1, you select read, and now you need to change the address again. Address will be from 200,000 to 3FFF. So again, we can just modify this one. We start from the place where that one finished and we end 2 megabytes later. So like this, it's already calculated, and we can start. Now P-flash1 is read. We save as P-flash1 298. This is our X backup, and we make also a bin backup. Okay, and that's it. Then we move into pflash 2, again from 400,000 from the beginning of from the end of the last one to 2 megabyte later. So here we modify the section again and start from 400,000, and it will end up at 5FFF, and we start to read this section now. Reading is done. Now we can save. pflash 2 as X and as bin. Then we move to the next section, our program flash 4. And it's the same logic again, so easy. We modify the address. As the size is always the same. And we start reading. Okay, so the pflash is done. This is the last part. We save as pflash 3. Also in binary. Then the next step will be to work on the dflash. This is the DF EEPROM, which starts at AF00 and then goes on for 768 kilobyte. So here we need to remember the address a little bit. So AF0000 to AF0BFF 768. Then we can read. Okay, we got our DF EEPROM. Again, we do the same thing like before. We save it in 2 formats. Next step, we move into DF1, and this one starts at this address, so we need to change the section again. So it's a different starting point from before. The size is also different. This is a 64 kilobyte. We need to go to F11 FFF 64 kilobyte. Okay, now we can just read, and it's done. It's probably empty. So we save it as DF1. Now it's our binary file also. Last is the user configuration block, the UCB. As you see, 2 areas are actually protected from writing, but we just need to read now. So we start from AF 100,000 and we finish at AF 101 FFF. 8 kilobyte file, so we can read. Okay, now we save. This file actually has data, UCB We usually don't need to touch this file, but we back up it in both ways. Okay, so our reading part is done. Now if you want to write a file, you need to select, for example, pflash-x, then go to the correct memory to match the data, and from here add the selection. Now you see it will be matching, and we can start to do program. So it will just erase program, and then we can verify as well. Yeah, all good, success. So we just programmed this memory. If we need to program the entire chip, then we will need to do the same thing for each memory. That's it. If you get stuck into connection because you get this error, there can be two possible issues. One issue is that the processor is not connected. Another issue is that the processor is connected well, but it's protected. In order to change the protection system, you need to go here and use this password. However, the password needs to be changed. Depending on the chip, the password will be different values, and each part must be matching exactly in order to get in. So most of the time, if the chip is protected, unless it's a chip that you modified yourself with a password, like for example here, then you will not be able to get the right password and you will stay unable to operate in JTAG mode. For that, you must use a different tool like Flex, TrustData, AutoTuner, or whatever that allows you to read the chip bypassing the protection.